All right, section 7.4 is about parallel lines and proportions. And there are some proportional parts within a triangle. In any triangle, a line parallel to one side of a triangle separates the other two sides proportionally. So, if a line parallel to one side of a triangle intersects the other two sides, that would be TU, that's the one they're talking about, then it divides the two sides proportionally. Okay, what that would mean is that QT is to TR as SU is to UR. Okay, I'm going to color code those just for a sec. So QT is to SU, you can go that way too, as TR is to UR. Now, the way I did it here was the bigger ones were on the bottom and the smaller ones were on the top. Okay, now I'm going to put some numbers on there, show you what I mean. So, well, maybe not yet. I think I'll wait for the next one. Well, maybe it'd be better if you actually saw it now. If I had a 2 here and an 8 here, those would be in the ratio of 2 to 8. 2 to 8 reduces to 1/4. So if this side was 3, this number would need to be, my pen's just stifled here, excuse me. There it is. Okay, this would need to be in the same ratio, this would need to be 12. Okay, so 3/12 would also reduce to 1/4. So the sides are proportional, meaning they are in the same ratio. Now, I'm not trying to tell you that that picture is to scale by any means. I was just picking some numbers so you could think about what this really means. All right, next, anybody still need this? Okay. Okay, can I go? All right. Converse of the triangle proportionality theorem, all it's saying is that if these were in that ratio, and I had put on there 2 and 8 and 3 and 12, so if that's true, so if 2 is to 8 equals 3 to 12, then you can say that the lines are parallel. So if the line divides the two segments proportionally, then it's parallel to the third side. And that would be TU is parallel then to QS. And that would be if these sides are in the same proportion. You did have another picture, right? Okay. All right, next. What is a midsegment of a triangle? Remember, like if you had, that's a terrible line there. You had a triangle, a midsegment was something that connected the midpoints of two sides. So if this side is cut in half and so is this one, and you got a segment connecting those points, then that is a midsegment. I chose not to use this triangle because I want to do something else with it. The midsegment theorem says, though, if a midsegment is parallel to one of the sides of the triangle, then its length is half the length of that side. Okay, so if this was a midsegment also, so say these two sides of pieces were 6 and 6, and over here it was 5 and 5, that would make that a midsegment, and this would be parallel to this side. And if this side was, say, 7, that little chunk right there, then this would be 14. So you can go forwards and backwards, meaning if the midsegment is half of the side, and if you got given the midsegment, you would double it to get the side. And if you were given the side, you'd cut it in half to get the midsegment length. All right, let's do number 1. In triangle ABC, that's the big one, EF is parallel to CB, so we're going to find X. Now that we have this triangle proportionality theorem, we can do things a little differently. Remember yesterday we had to add 18 and 6 when we did it, the proportions? We had to add this side to get the whole side, etc. Well, now we can do, because they're parallel, that these segments cut these sides into parts that are proportional. So we can actually do something different today. We can go 6 over 18 would be equal to x plus 2 over x plus 22. Okay, so what's happened is those parallel sides have cut these into proportional parts. All right, these parallel lines. Now, cross products are congruent, so we're going to multiply 18 times x plus 2. And that will equal 6 times your x plus 22. Distribute carefully. 18x plus 36 equals 6 times x plus 6 times 22. 120, 132. All right, then, oops, I got some stuff left over down here. Like crumbs on the table. All right, can get our x's on one side. We'll subtract 6x from both sides. That'll give us 12 times x plus 36 equals 132. You guys are probably ahead of me and already got the answer. Subtract 36. What I end up with? 12 times x equals 96. Okay, and then I divide by 12 and I get 8. All that work and we found 8. Okay, number 2, the example has triangle GHJ with KHK being 5, so I'm going to label that. KG10, and then it says the JL is half of GL, or LG. So the hint was, let's let JL be X and GL be 2X. Why? Well, it said that JL is half of GL, so if GL is 2X, half of 2X is X. All right, now it says, is JH parallel to KL? That's the question. It would be if, it will be yes, if 5 is to 10 as x is to 2x. Well, no matter what I do, if I cross multiply, aren't I going to get 10x? I'm going to get 10x equals 10x. That's one way to look at it. And since that's true, then yes, those are parallel. Another way to look at it, though, is this. Is 5/10 the same equal to x over 2x? Now I'm going to think about it differently. I'm not going to cross multiply. Okay, that's a good way to do things, but we had another way. What was it? What do we do with the fractions instead of cross multiply? Simplify. So reduce. 10 divided by 5 is 2. 5 divided by 5 is 1. This is 1/2. And then you could cancel out the x's or divide by x top and bottom. And then you'd have 1/2. And so since 1/2 equals 1/2, that's another reason why our way to show that yes, those must be parallel because the sides are in the same ratio. All right, next. You've got to turn your page, I think, or yeah. 7.4 proportions and parallel lines continued. Now we've got some examples of what your types of questions you will see in your quizzes, etc., and in your practice. You can go the way it looks. There are 4 ways, remember, to write a proportion correctly. You could write 20 over x, just do it like it looks, 18 over 9. I see a lot of students just writing this on their paper. What's missing from this? This is not an equation at all because it doesn't have an equal sign, okay? You need an equal sign between there, please. The only reason we can cross multiply is because there's an equal sign between the fractions. So let's do it. X times 18 is 18x. 9 times 20 is 180. Next, we divide by 18, and we're already done. We found that x is 10. The next problem shows tick marks. Those tick marks indicate that these sides are congruent to one another, which makes x a midsegment. It is a midsegment because these sides are bisected. All right, if it's midsegment, then x is equal to 1/2 of 35. 35 divided by 2. And that would be 17.5. Okay, no proportion for that one. But the next one, we're going to talk about, oh my goodness, look at all those lines. We have 3 parallel lines, L1, L2, and L3. They are cut by transversals S and T. Remember, that's called a transversal. These are transversals. Over here, the transversals are the lines N and M. What the proportional parts with parallel lines thing says, when 3 or more parallel lines cut 2 transversals, they separate the transversals into proportional parts. If the ratio of the parts happens to be 1, then the parallel lines separate the transversals into congruent parts. So, you can see the fractions right here. A over B equals C over D. Over here, U is to W as V is to X. And going the other way, U is to V as W is to X. And that's what it says down here. If U to V equals 1 and W to X equals 1, that means they are congruent pieces. Okay, these would be equal to one another, and these would be equal to one another. All right, so here we go. We've got some problems that have parallel lines, 3 or more parallel lines cut by transversals. This is showing these are congruent. So to solve for x, I'm going to do 3x minus 1 equals 2x plus 4. Okay, so since 2x plus 4 is marked 3x minus 1, what else is true? Well, that would tell me that over here, 3y equals 2y plus 2. All right, because those are equal, then these pieces must be equal as well. All right, so I'm going to subtract 2x and start my solving. Got my equations I need. I got x minus 1 is 4, and then we add 1, and we get 5 for x. And then for y, we're going to get that one really quick, because all we got to do is subtract 2y, which gives us y is 2. All right, using this is different. This one does not show any congruence, so we need to set up a proportion for this one. 3 over x, just go vertically, x 4 over x plus 4. Remember, there's 4 ways to correctly write a proportion, so I'm not telling you that this is the only way that it can be written. I just think the kids see it very well because they're right one above the other. Okay, cross products are equal. So we do 4 times x equals 3 times x plus 4. Now, I've been asking my classes, so I'm ready to ask you guys, how many of you are writing 4x equals 3x plus 12 right away? Like you're not writing this step, you're doing, okay, that's good. If you still want to write this stuff, that's fine. I might stop doing it pretty soon, since we've been studying these proportions for several days, or a few days. 4x minus 3x is x, and then I get x is 12. I think that's for the ISN, correct? So we're going to go to the packet that you grabbed. I don't know why I'm on the homework part. Looks like I got some erasing to do. I accidentally pulled up when I've already filled in again. Okay, you've already got most of this already filled out on your paper, but I'm going to have you add a couple of things, which will be in just a second. Should turn this thing off for a minute. Okay. So we've already gone through this in our ISN, but let's just quick look at what it said. If in any triangle, a line parallel to one side of a triangle separates the other two sides proportionally. The triangle proportionality theorem that we just got through using is if a line parallel to one side of a triangle intersects the other two sides, it divides the sides proportionally. All right, you don't have this, so you might want to add this onto your page. You have this picture. And if T is parallel to QS, what we wrote in our ISM was then QT is to TR as SU is to UR. Okay. These parts are proportional. If you like color or you use the highlighters, then I would highlight those two the same color and these TR and UR the same color. Okay, and then, oops, I guess I should color my statement here. The Q and the T, the S and the U, that were on, those were on the top, and then on the bottom were these. The next part is the converse, which we discussed already, and you might want to add on to your sheet that you've already got this all filled out, and it says that if a line divides the triangle proportionally, then it's parallel to the third side. So we can prove some things are parallel by the converse. So, what was I going to write here? I forgot. All right. If KH is to KG as JL is to LG, then KL is parallel to HG. HJ, not G. All right, so what this is saying is that if these were proportional, I'm going to put some numbers here. Say that was 2 and this was 6. And then this was 3, then this was 9. Then because 2 is to 6 as 3 is to 9, and they both reduce to 1/3, then those lines would be parallel. Those segments would be parallel. Anybody need this still? Oh, okay. What is a midsegment? Again, a midsegment connects the midpoint of two sides. So this side would have been bisected and this side would have been bisected. The midsegment theorem says if a midsegment is parallel to one of the sides of a triangle, then its length is half the length of that side. Okay, whoops. I think you have, doesn't yours have a line already on it? Right here? Okay. If you know, if X is your midsegment, 2X would be the bottom, the parallel side to it. And these would be parallel. So if they're parallel, then if the bottom is twice 2X, then the midsegment would be half of that, which would be X. All right, here we go. We want to determine whether QT is parallel to RS. Are they parallel? Well, if they're parallel, then these sides should be split proportionally. So 18/38 should equal 36/80. Now, these numbers are larger. You may wish to use your calculator to reduce them. I'm going to do it with facts. 18 is divisible by 9, and I can cut 18 in half, and I can cut 38 in half. So therefore, I'm going to do that, and I'll get 9/19. 36 and 80, I can divide them by 4, and that would be 9 over 20. I didn't get the same answers. So that means these are not equal, which means that QT is not parallel. So no, QT, oops, I wrote that goofy, is not parallel to RS. Let me write that QT better. So segment QT is not parallel to segment RS because the sides are not cut proportionally. All right, number 2. Oh, got to remember that I haven't erased. Let me erase a couple pages. Look at number 4 real quick. What do you think? What do you think X is? Oh, geez, what's all that? Oh, no. Guys, I've had that question on a quiz and had people miss it. That's worrisome. It's the problem. Oops, I already did that one with you. This problem is so obvious that people miss it. What should X be? Do you need to write a proportion? No, X needs to be 7. If these are equal, these have to be equal. Okay? So you could write a proportion. 5 over 5 equals 7 over X. That would just been 5X equals 35, and then you divide by 5 and get 7. So there's proof for it right there. Okay? This one, quick, X over 24. Because the lines are parallel here, these sides are cut proportionally. That'll equal 10 over 30. Now, I want to point out that what if you see it differently? Did anybody write this one already and write X over 10 equals 24 over 30? Did anybody do that? Or think that? This is perfectly fine because the same things are across from one another. All right, 30 times X equals 24, forgot the X. 24 times 10 would be 240. We would divide by 30. And what's X? Okay, quick, we got 8. Everybody can do this. 6. Got a little issue I need to take care of right away. I can see my X, and it compares, I can do X and 11 are corresponding. Let's see, these need to be the fractions I'm going to do. I'm going to do red over blue. X over X plus 12 equals 11 over, what? So I have something on for the blue part? This part? How am I going to get it? So I've got 33 for the whole side. I need to subtract 11 and I can get 22. All right, there we go. Now cross products are equal, so let's go this way. 22x equals 11x plus 11 times 12, 132. I need to subtract 11x. I get 11x equals 132. And then I divide by 11, and I'm all the way back to the number. The answer is 12 for x. Hope that makes some sense. If you plugged it back in, this would be 12. This would be 24. All right, let's go this way. X to x plus 10. And then over here, what will we start with? So we start with x over x plus 10. How's it going to go on the other side? You don't want to, like some kids make the mistake of doing 30 over 10. It's not 30 over 10. It would be 10 over 30. Okay, cross products. I got 30x equals 10x plus 100. I am going ahead and just distributing it. And then I'll subtract 10x. I have 20x equals 100, and then I divide by 20, and what do we got? Yep, 5. Okay, I hope not too bad so far. Now we're going to go to that proportional parts for parallel lines. 3 lines cut by 2 transversals. Let's just do it. All right, from the diagram, we know A over B equals C over D. You can also go A over C equals B over D, because you'll still have the same stuff across from one another. So you can go that way as well. I like to go the way the fractions are just sitting there in front of my face. And now I'm going to plug in the A is 3, the B is 8, the C is 5, and they want us to find the D. Cross products are equal, so 3 times the D value equals 8 times 5, 40. And then we divide by 3. Now, we've been doing this so long that I didn't even show dividing by 3 on both sides. That's what we did. Now, 40 divided by 3, you can leave it as a fraction like that, or you can change it to 13.3 repeating, or 13 1/3. Any of those answers is equivalent. Oops. Number 9. Oopsie, I have to erase. All right. Now, I have a reason the way I want to do this one. So, if anybody already set it up, do you have a 5x and a 3x, one on top of the other? And that's going to be a problem if you don't, because I'll show you why. If I go vertically, I'm going to have some issues with solving. I want to go this way. Because these are the parallel lines. That transversal is cutting through those parallel lines, and it creates the parts that are proportional to the other side's parts. So it's 5x over 3x. And that equals x plus 12 over 12. Now, what could I do about these x's here? Because I don't feel like having so many x's in my problem. I could reduce this by dividing, because these are in a ratio of 5 to 3. So I'm going to divide out those x's. So now I'm going to do cross products, and I'm going to do 5 times 12 and 3 times x plus 12. So 3 times x plus 12 would be 3x plus 36. 5 times 12 is 60. And now solve. Subtract 36 from both sides. We'll get 3 times x is 24. Divide by 3 on both sides, and we will have x is 8. What's the matter? Did I do something wrong? Isn't that 24? Yeah. Where did I lose you, hon? No? You sure? Okay. You guys understood why I could cancel out those x's on that first fraction? We're all right with that? If you went vertically, it makes a big mess because you're going to get x squared and stuff in your problems. So that's how we want to do this one. All right, new 10. We've got some parallel lines and some triangles and stuff here. If you got this marked on the left that these segs are congruent, that would mean the segs on the right are congruent also. Because the ratio is 1 to 1, we can pick any pair. Don't let this confuse you because there's 3 things. Pick a pair and set them equal. What's the easiest equation I could write? How about I do x plus 3 equals 12. All those segments are 12. So if you want to solve for x, just set x plus 3 equal to 12. Subtract 3 and we get 9. If you were to plug 9 back in here, you would find out that gives you 12 for each segment, which is what they should be. $11. Ooh, special. We got fractions. Don't let this bother you. I will help. You got parallel lines. It shows that these two are congruent. Therefore, these two segments are congruent also. So we're going to do 3x minus 4 equals 5/4 x plus 3. Now, I think we might as well change 5/4 to a decimal. If you think about money, that's 5/4 quarters, which would be 1.25, $1.25, if you will, plus 3. We can subtract 1.25x from both sides. What is 3x minus 1.25x? 1.75x, okay? Then minus 4 equals 3. We now need to add 4 to both sides. We get 1.75x is 7. We have to divide by 1.75. So x is, you type on your calculator, 7 divided by 1.75, you're going to get 4. Okay. I really find it frustrating when I look around and see people with the calculator sitting in front of them, because with it under their paper or not open, and that's just because you're not going to remember a lot of stuff if you don't do this with me. 2/3 y plus, oops, I wrote 6. What's it supposed to be? I did a boo-boo. 3. Those are equals 1/3 y plus 6. And that's the only reason I said that is just doing the work with me and just not writing it down and zoning out helps you learn. All right, what can I do? Any ideas? I know you guys don't like fractions, but we're going to deal with it. We're not going to change the decimals. You got to get something on the y's on one side, right? And it's convenient that this is 2/3 and this is 1/3. So if we take away a third y, it's not that big a deal. 2/3 minus 1/3. Just listen to what you're saying. If you have 2 of something and you take away one of them, how many do you have left? 1. So we still have a third y. Okay, 2/3 minus 1/3 is 1/3. We got 1/3 y plus 3 is 6. Next, we would subtract 3. And 1/3 y is 3. And then I want you to delve back into your memories and say, what did the teacher tell me in Algebra 1 what to do when I had a fraction in front of my variable? They probably said multiply by the, and I call it a reciprocal. Okay, and you guys said reciprocal back in Algebra 1. All right, and I've said it before too. So all we have to do is multiply by 3. Multiply by 3 over 1 or by 3. Okay, so that'll get rid of that, and you'll end up with y is 9. Done. All right, find x and y. 5 over 8. Boom, let's just go. 5 over 8 equals y over y plus 2. Those are so easy to set up. Cross multiply. 8y equals 5 times y plus 2 will be 5y plus 10. And that, ooh, I got an answer showing. Oh, my little eraser. Stop it. I hate it when it does that. Oh my goodness. Okay, back, there we are. I think I somehow took a picture without meaning to. All right, subtract 5y from both sides. You guys are getting a fraction again, aren't you? All right, you're already there. You got 3 times y is 10, and then you just divide by 3 and you write 10/3. Or, if you divide it on your calculator, 3.3, and it keeps going 3, 3, 3, 3, 3, and I hope your teacher taught you to put a bar over the repeating part. So at least do that, 3.3 repeating, or you can write 3 1/3. Okay, this one, let's just go for it vertically if you want. 16 over y is 32, equals 32 over y plus 3. I'm going to cross multiply. I got 32y equals 16y plus 16 times 3 is 48. All right, subtract 16y from both sides. I get 16 times y is 48. And then finally, divide by 16, and I'm going to get, sorry for my writing all over my picture, y is 3. Lucky number 13. Okay, and then 14 is streets, and I just showed you the answer, but this is no different than what we were just doing, so don't be afraid of these word problems. 1 is to 0.8 as 1.4 is to x, because K and Bay Street are parallel. K Street and Bay Street. Cross multiply, we get 1x right away. So we just need to find out what 0.8 times 1.4 is. And then we need to label it, and it's 1.12 kilometers. Okay, you've got some homework practice to do. Don't forget that tomorrow we still have about 4 minutes, so stay where you are. Oh my goodness. The homework tomorrow is Thursday, well, excuse me, whatever day it happens to be if you're listening to a recording. We're going to talk about 7.3 and 7.4 questions. So please be prepared with ones you would think you need some help with by trying the problems first.